Alright, in this video here we're going to be talking about some trigonometric identities. So first off, what an identity is. An identity is an equation that's true for all values of the variable or variables if there's more than one variable in there. So no matter what number you plug in for x or y or t or whatever the variable is, the two sides of the equation are always going to be equal to each other. They're identical to each other. That's why we call it an identity. Alright, so it's an identity is an equation that's just always true no matter what. Alright, so the first few we have up here, and if you've watched some of the other videos that I've done on trigonometry, the first ones that are already up here, I've already talked about these on other videos, so I'll just kind of go through these real quick, and then I'll put up a couple other types of identities that we'll talk about in a little bit more detail. But the first ones up here in blue are the reciprocal identities, right? So cosecant is the reciprocal of the sine function, secant is the reciprocal of cosine, right? Cotangent is the reciprocal of tangent. Right, and like I said, if you've been following along and doing the trigonometry stuff, you should probably already know that those reciprocal properties are true, right? So those are our reciprocal identities. The three of our trigonometric functions are reciprocals of the other three, basically. All right, the next two up here are how we can write the tangent and cotangent functions in terms of sine and cosine. Right, tangent of x is equal to sine of x over cosine of x. Cotangent of x is equal to cosine of x over sine of x. Right, remember, up here we said that cotangent and tangent are reciprocals of each other. So if tangent is sine over cosine, cotangent is the reciprocal of that. You flip over the fraction, it's cosine over sine. Right, and this goes back to the unit circle definitions of the trig functions. Remember, sine is the y coordinate, cosine is the x coordinate, tangent is y over x. Well, if tangent is y over x, y is sine, x is cosine. So tangent is sine over cosine. All right, so those are, taking our, really we can take any of the, other than sine and cosine, we can take the other four trig functions and write them in terms of sine or cosine. And that's something that we'll do with kind of like what I have coming up in the next couple of videos, which will be, simplifying trigonometric expressions or proving that trigonometric identities are true. A lot of times one of the strategies that we use is changing things to be in terms of sine and cosine. So like if I have a cosecant, I can write that as 1 over sine, and I have it in terms of the sine function now. Or I can take secant, and I can write it as 1 over cosine. Now I have secant in terms of the cosine function. And I can take tangent and cotangent and write them in terms of sine and cosine by using these two properties in black up here. All right, so these ones we will be using when we are proving trigonometric identities and simplifying trig expressions. We use these properties here, the blue ones and the black ones, kind of a lot. Right, we also use these ones fairly often when we're doing those same types of problems. These are what we call the Pythagorean identities. Right, so sine squared x plus cosine squared x equals 1. Right, that's the major one that you need to be aware of. And then the other two here, the other two Pythagorean identities, those two spring directly from that first one. Right, so if I take the first one here, and if I divide everything by cosine squared, well, sine squared over cosine squared, sine over cosine is tangent. So that would give me tangent squared. Right, cosine squared over cosine squared would be 1. 1 over cosine squared, well, 1 over cosine, that's secant. So 1 over cosine squared would be secant squared. So we get the related identity, tangent squared x plus 1 equals secant squared of x. Right, and if I went through that too fast just now, I did another video the first time I talked about these trig identities where I explained that in a lot more detail, and I think I even wrote it all out. So you might want to check out that video there where I explain how to get these two identities from that first one, sine squared plus cosine squared equals 1. All right, the last one, 1 plus cotangent squared of x equals cosecant squared of x. For this one, if we go back to that original again, if I take this equation and I divide everything by sine squared of x, it's going to give me that bottom equation. Right, sine squared divided by sine squared is going to be 1. Right, cosine squared divided by sine squared, well, cosine over sine is cotangent, so that's going to give me cotangent squared equals, and then 1 divided by sine squared, well, 1 over sine is cosecant. So 1 over sine squared is cosecant squared of x. Right, so these two Pythagorean identities come from that first one. So it's really important to remember the first one, sine squared x plus cosine squared x equals 1. That comes up all the time when you're trying to simplify trig expressions or solve equations or prove trigonometric identities. The other two will come up once in a while. It's not like you're never going to need these. But you don't really have to memorize these. If you understand what I just said if I take this one and divide everything by cosine squared, I get this one right here. Well, then you don't have to memorize this one. You can just say, well, I have this problem here that has a secant squared in it. let me go back to this one and do everything divided by cosine squared, and now it gives me the identity I need to use for secant squared. Right? Or if you need to use this one, if you have a problem that has a cotangent squared in it, go back to this and say, okay, cotangent squared, let me divide everything here by sine squared, and then that gives me this identity, and then I can use this one to work with my cotangent squared. Right? So it's not necessary to memorize those last two if you understand where they come from, which is the sine squared plus cosine squared equals 1, dividing everything either by a sine squared or a cosine squared to get these other two. All right, so those are some of the trig identities. Some of the ones, like I said, we've seen before if you've watched the other videos that I've done leading up to this, throughout the trigonometry stuff. So those should be nothing new to you at this point. But what I'm going to do now is pause the recording and erase these and put up some more identities that I haven't done videos of yet, so there may be things that you haven't seen before. Alright, so I have up here a few more identities that, like I said, I haven't talked about in any of the other videos that I've done so far yet. And the reason I haven't mentioned these so far is because they're really not that important. They don't come up that often when we're doing the types of problems I mentioned before, which was, solving trigonometric equations or simplifying trig expressions or proving identities. These things you hardly ever see when you're doing that, but they do exist. These are trigonometric identities, so and show you what they are just so you're aware that they exist, and if they ever do come up in whatever problems you may be doing, you'll hopefully at least remember that they're there and you can use them if you need to. So the first ones are called the even and odd properties for even and odd functions. So the sine of negative x equals negative sine of x, right? Because sine is an odd function, right? Cosine is an even function, so cosine of negative x equals cosine of x. Right, and then tangent is an odd function. Tangent of negative x equals negative tangent of x. Right, so those are called the even odd properties of those three trig functions. Again, they hardly ever come up, but they might at some point in time. The other ones we have up here are called the cofunction properties. It's how the sine and the cosine are related to each other, how tangent and cotangent are related, how secant and cosecant are related. And if you watch the videos that I did on the graphs of the trig functions, you may probably noticed this already. And I may have mentioned it a little bit when we were doing that kind of stuff. But sine of pi over 2 minus x equals cosine of x, and cosine of pi over 2 minus x equals sine of x. Right? The sine and cosine functions, if you think about the graphs of sine and cosine, they're both those waves that go up and down between +1 and -1. Right, but they have different starting points. Basically what this is saying is that these two functions are just horizontal shifted pi over 2 units, right? That's why we have that pi over 2 there. If you take the sine function and you shift it pi over 2, you get the cosine function, right? If you take cosine function and you shift it pi over 2, you get the sine function. Right, so if you don't believe me, go back and look at the graphs of the sine and cosine functions, and you'll see that that's true. And it's also true of all of the other functions with their cofunctions, right? So the same thing with tangent and cotangent, right? Tangent of pi over 2 minus x equals cotangent of x. Cotangent of pi over 2 minus x equals tangent of x, right? So once again, the tangent and the cotangent are, well, it's two things really. It's a horizontal shift, pi over 2, and also there's that minus x. The minus x means you reflect it over the y-axis, right? So if you move the graph over pi over 2 units to the left and then you flip it around, if you do that with a tangent function, you get the cotangent function. If you do that with cotangent, you get tangent, right? Same for sine and cosine, right? You move it over and then you also flip it. For sine and cosine, when you flip it around, not much happens, but it is part of the technicality of what we're doing here. And then same thing for secant and cosecant, right? Remember, the secant and cosecant graphs were the ones that were like the U-shapes going up and the U-shapes going down. The two graphs look very similar to each other, but they're just offset from each other, right? They're not exactly the same because they have different starting points, right? They're horizontally shifted from each other, right? So secant of pi over 2 minus x is the same as cosecant of x. Cosecant of pi over 2 minus x is equal to secant of x, right? So you can use these properties here. Like I said, they hardly ever actually come up in problems, at least not the kind of problems that I usually do with the classes that I teach. But if you have a cotangent function and you need to write it, like it has to be in terms of tangent, you can say, okay, well, cotangent of x, let me write that as tangent of pi over 2 minus x, and now I have a tangent here instead of a cotangent. Right? Like I said, it hardly ever comes up, but if you need to write the function, like I have a cosine here, but I need this to be a sine, all right, change cosine into sine of pi over 2 minus x, right? So you can do those kinds of things with these properties here, right? These ones up here, if you have a cosine of negative x or a sine of negative x and you need that x to be positive, that's when you can use these even-odd properties up there in blue in order to make that happen. All right, so those ones hardly ever come up. But there are a ton of trigonometric identities, and in some of the future videos that I'll be doing soon, we'll look at some more trigonometric identities. There's a whole bunch of formulas that go along with trigonometry. So trying to memorize all of them is just absolutely ridiculous. Like most people, like PhDs in mathematics who teach mathematics all the time, don't have all of these properties memorized, but they know that they're there. So if they're doing a problem and they see something like this, they're like, oh, there's a property for that, let me look it up and find it. So that's why I'm showing these to you, just to make you aware that they exist. And then if it ever does come up in the future, to just think, well, this is a trigonometry thing. Maybe there's a property out there that I can use to simplify this, and let me look it up in my book or look it up online, to find the property I need, and then you can find it and use it to solve your problem. All right, so check out the next video that I do where I am going to be using some of these properties to actually simplify complex trigonometric expressions.